Okay, last session we talked about class and object. I put that in the notes.md. Okay, so today we'll be talking about very basics of Java. In last class we went through primitive data types a little bit. So we will start with the primitive data types and non-primitive data types, and then mathematics operations library and typecasting, and then arithmetic and comparison operators we will see, and then strings, if else if, and a switch case. We'll be having here for loop, and then while, do while. Yeah, those are pretty much. We will cover first
Hello.
today if possible. After we cover this 7, we will get into for loop and while, do while in the next session. If possible today, we will close it. We have 45 minutes time. As much as we can cover, we will cover it. So getting into primitive data types. As I mentioned, primitive data types, which defines the value of the data, what type of data it is. Let's say if you put, for example, 2, which is an integer, right? If you put 2.2, that is a float. If it is a bigger number, double. So each data type has its storage capacity, right? So we will define what are different types of primitive data types. Smallest one is a byte, which is 1 byte storage, which means like 8 bits, 1 byte storage. And second one is chart, which is a 2 byte storage. And then integer, which is a 4 byte storage. Each byte is 8 bits, right? So this is 8 bits. 2 multiplied by 8, 16 bits. As such, 1 byte is equals to 8 bits, which means like it will take like 1 byte is 8 bits. Integer, and then float is also same, 4 bytes. And then double, 8 bytes. Whole. Whenever in a programming language we need to, in any programming language, if you go to SQL or Python, any other language, pretty much will be having similar sort of a primitive data types. All these data types having some storage capacity, right? So when I say 8 bits, how many store minus 2 to the power of n to plus 2 to the power of n, which means like 2 to the power of n minus 1. Here we said 1 byte, right? 2 power, sorry, just a minute. 2 to the power of 7 minus 2 to the power of 7 to plus 2 to the power of 7. That much of storage we can do for 1 byte. For a short, it will be doubled, which is like 8 bits. It is a 16 bits, right? Minus 2 to the power of a 15 to 2 to the power of a 15. If it's a 4 bytes, 4 multiplied by 8, 32, which is like 2 to the power of 32 minus 1, 31. Negative 2 to the power of 31 to positive 2 to the power of a 31. You may be anyone, whoever asks what is the maximum capacity int can hold, then that is 2 to the power of n minus 1, that is the maximum positive way. 2 to the power of n represents number of bits. 4 bytes is the storage capacity, and bits, to convert 4 bytes into bits, 4 multiplied by 8, 32. 2 to the power of n minus 1, or 2 to the minus 2 to the power of n minus 1, which means like 2 to the power of 32 minus 1, 31. So you could say minus 2 to the power of 31 to plus 2 to the power of 31. That is the maximum capacity of integer type data can hold number. And the float is also same. Double is 8, which is double than integer and float. And then we have a boolean. Boolean is just a true or false. It takes like 1 bit size. Is just 1 bit. It is not byte. Careful. 0 or 1. It just hold 1 character. And then we have a integer float double, and we have a long, which will hold these 8 bytes of a same as a double, 8 bytes. And then we have another smallest one, character, which is a 2 byte storage. Okay. These are the primitive data types. We will see a simple example defining a variable using the primitive data types. What else we have? Non-primitive data types. Non-primitive data types means it can be a string, arrays, or objects, classes, or interfaces. All those come under non-primitive data types. So one is classes, objects, interfaces. We'll talk more about interfaces, classes, and objects again in OOP concepts, strings, and arrays. These are the non-primitive data types. We will talk about arrays in a separate class. Arrays is a collection of similar data types. Let's say we want to define 8 integers in an array. So we can define that in an array saying that 1, 3, 5, 7, 8, like that. That's an array, declaring an array. When we get to arrays concept, we will talk about the syntax. How do we define an array? How do we initialize that one? Okay, intention of this class is to give a simple introduction about primitive data types and non-primitive data types. We talked about a class yesterday, class and object. Class is a collection of data members and member functions. Data members is nothing but variables, you could say, or attributes of a class, you could say, right? Whenever you define a name that become a constant for a person, name is not going to change that frequent, or you can make it as a variable if that name is changing, depends on the need, we could say. So these all are defining the variables. To define a variable, we will use the primitive data types. These all are like standard Java API providing primitive data types. Let's say if I want to define something, a person object, instance of a person class, or instance of a pet class, or create an object and hold some data, all those would come under non-primitive data types. For these, we don't create any objects or anything. We just define type and use it, right? When you see here, what is the syntax for the syntax for a data member to define data type, variable name, and assign the value, right? So here, what is the data type? Let's say I'm defining a character. I just want to define a character, which is a char, and Variable name is user defined variable name. Means like developer can provide whatever name developer wanted to define, right? Let's say I want to define sample character. How do we define a character? With a single quotes, and you define a single letter only we can define, that is called character. Collection of characters become a string, collection of strings become a statement, right? So I'm defining just yes, this is the and semicolon. This is example of defining a character variable. Let's say I want to define an integer variable. What we can do similar way, int data type, and you can say sum is equals to 0. That is an integer. If we want to define a float, we can say float and sum float type is equals to, you can define 2.3. That is the float value. We put f in a float and so on. We can define as such variable names. Here we are using primitive data types, which is coming from the Java API. Whereas in non-primitive, when we are defining a string, how do we define? We use the class type string, and sample string is equals to define hello world. And we want to define a person class object. We will use that with the new keyword. When we get to classes and objects, we'll talk about class, object, and interfaces there. And defining arrays also, similar way we could define the syntax. That's the more about primitives and non-primitive data types. Getting into math and operations and casting. Math library in Java API, which provides, we can perform any mathematical operations. Math library, using math library, you can find minimum between two numbers, max between two numbers, power of, let's say, 2 to the power of 5 or 2 to the power of 6. We can calculate any trigonometric or any geometric, all those APIs, square root or square of a number or quadruple of a number, whatever whatever algebraic equations we do have in a mathematics, all those can be performed in using the math library. So in a routine programming language, we don't use much math library, but if you are working on any data side of the projects, some of the data scientists would use this math library if they are using Java language as a base, but majority they use Python libraries in different situations, which would provide different APIs. But underneath those APIs, similar sort of these logics, whatever this Java math API is providing, similar sort of logic will be hidden. We don't need to no need to know what the logic, but if we able to know what are the APIs and what are the functions available, that way you can get to know. ID is majority of the time will give a help. When you put math dot in control space, if you hit, you will be getting list of operations. Or if you go to java.lang.math library, you'll be able to find all the operations in that API. I'll show you Java API classes, how to get through it and read through. And then we have Math operations. We'll do an example on that math operations, writing a code, and you guys can see how math operations can be performed using the Java library. And then we have a casting. Casting means, let's say, here we have float, right? We wanted to convert a float to integer or integer to float, or convert a character